My name is Steve Poole. I'm a developer advocate for a company called Hero Devs, who provide support for end-of-life software. We have a booth. Encourage you to go talk to them. This talk is obviously a technical talk. I've been doing Java since it was less than one. Right? I used to work at IBM for a long time doing lots of Java. So I've been on the other side of Java for a very long time, and done JVM engineering and stuff like that. So I've got a good understanding of a lot of what's going on here. What I did was basically sit down and try and figure out all the changes that have been documented, or maybe haven't quite been documented, between Java 8 and 25. So I'm going to take you through what I think are the gotchas. I think I've got them all. There's probably bound to be one or two edges. Some of them may surprise you. And I also want to talk about why Java 25 is the right place to go and why you should be moving there, regardless of what are effectively some small minor changes. I'm also writing a book, I'm just promoting it, which is called Practical Dependency Resolution, with a friend of mine whose name hasn't come up, Hervé. He's a Maven committer. That QR code takes you to a website. So if you're interested in getting a sample of the book, then you can go there, or you can come along to, again, you can come along to the booth, right? And the URL there is a Substack version of this talk. It's slightly older than this talk, so I think there may be one or two changes, but that's where I tend to publish stuff. Right, so who here is a Java developer? Good. Who's on Java 8? Who's on Java, what should we pick? 17. Good, okay. And anybody who's going to go, we're mostly on something else? Yeah, okay, right. So the migration from 8 to 25 is not a version bump. Somebody may say to you, well, it's just Java, you just go up, but we know it's not the case, right? When I started looking into this and going, how do you view the changes that are going to get in the way, I have a lot. So I'm going to talk about some tools that you can make use of, and then I'm going to talk about what's changed, what won't start, what crashes, stuff like that. We'll talk a bit about what recompilation challenges you may find, because there are some things there, and then there are bits and pieces. Okay, so I'm going to try and get all this lot through, so we may go fast. Okay, right. So let's start with who's doing this? Well, as I just asked you, it's like, who's on what? Well, 30% are on Java 8, 35% are on Java 17, according to New Relic. I think you know that. You probably have estates of that sort of mix, and we just have lots on Java 8. Okay, so let's start with some tools. I'd like to help you figure out how to find out the problems. So what tools are you going to use? Well, we're going to talk about static analysis tools, things you can apply to the binaries that you've already got, and then tools you're going to need when you're running things. So migration isn't take Java 8 code, compile it, run it on 25. There's more prep required for that to be a nice journey. Okay, so you're going to need to apply some tools to get some information out so that you can make better decisions, right? I mean, you can certainly hit it with a hammer until it works, but there's a bunch of stuff that is just, you should know up front. So the static analysis tools, jdeps, jdepscan, jnativescan, Java P, blah, blah, blah. I'll talk about those, all of them in a second. These are all tools that are available to you now. Most of them come with the JDK, and you can use them to analyze things about your binaries, right? And then we're going to look at some of the command line options and related tools that you need at runtime. And some of those may not be obvious to you, because a lot of these things have grown up over the years, and they're just there because there's lots of rich APIs available to us. So we're going to go through these. Going to go through them fast. Right, so JDEPs. Scans for the bytecode for dependencies on JDK internal APIs. It's a great little tool to tell you that you have a dependency on something, right? Now, when I say run it, pretty much every time I say that, I mean run it on the classes that are your compiled code, but every dependency that you have. The most important thing you have to do is get a look of your real estate and go, here's all the dependencies. And it's not just runtime, it's compile time, it's build time, it's test ones. You're going to move your Java runtime from 8 to 25. That everything that you ran on 8, even if it wasn't part of production, is going to have to go as well. So you need to know. So you need to get a complete list of every jar that you use, right? And then you're going to go through and run things like this, and it will spit out a whole bunch of verbosity about dependencies that you have, okay? It's a straightforward tool. You run it with dependencies, you'll get a list of things that you shouldn't be dependent on. Now, whether or not you're allowed to use them is a second thing, but that's what that tool's for. So what you can then do is you can run a different call tool, jprscan, with --4 removal, and that will do similar, but it's going to tell you the ones that it knows that have been programmed in to tell you that these are going to be going to disappear in a future release. So obviously, if you're in Java 8 and you run this tool and you get these list of dependencies, these things of going, you know they're probably gone because you've got 17 different releases between now and then, okay? So it will catch all sorts of bits and pieces that have disappeared. So it's an awesome tool to run, but again, you've got to run it on all your dependencies, right? You can't miss things out because otherwise things will fail. And then there are a few other tools. JNative scan, JNI calls, right? It's got FFM API usage, so it's new in Java 28, right? So it's not going to take great for you to use it won't be in the JDK 8 code base, but it's still a tool you can try, and it's certainly a tool you want to get your head around, right? It says down here on 20, these produce warnings. On future JDKs, they will throw errors. So what's going on now is starting to say, here are the tools for you to analyze what you've got, and they're going to tell you what you're going to lose next time, which is why you need to start thinking about learning these tools that will give you that information for the next upgrade, because they're only 6 months away. Okay. Then there's Java P, which has been around forever, which is the disassembler. And that one, with a bunch of things applied to it, is you're going to use this to find out whether your classes are making use of an API. So it's a bit clunky, but you basically can disassemble the class, grep for something you want to use. You can certainly go write your own scanners. It's not particularly hard, but you can use what's there, okay? I haven't finished, one more. JAPI Comp. So this is a tool, plugin I think it is, that you can use to compare two APIs from a binary point of view, right? So you can say, here's old jar, here's new jar. So that is definitely something you're going to want to do if you're thinking that as part of the upgrade, you're going to upgrade your dependencies. So if you're going to use Tomcat 8.5, you want to move to 8.6, they're old versions, you might use this tool to work out what the API difference is. And then if you're really sophisticated, you can take that difference, use the Java P thing, go see if you've got any. See the work that you could do? Now there are some runtime stuff you can do. This is just sort of like a one-off, right? You can do this print flags final, and it will give you all the flags that are supported. And you can apply these on different releases. And you can use that to work out what flags have come and gone. And obviously flags that have disappeared, you can go, am I using that? So everywhere that you've got a launcher and you're running Java, whether it's in a container or a script or whatever, that command line you use where you pass things in, some of those may be obsolete. And so you need to be able to understand how you're going to discover those. And so this is just a simple way of getting a list of all of the available command line options. So at least you've got a canonical list and you can go see whether they're supported. Right, okay. So that's the static analysis stuff. Runtime. Well, there's some command line, there's some, again, more command line flags that people probably don't know. So x log exceptions equals info, right? This will log every exception that occurs, even if it gets swallowed by an application. Why is this important? Well, because there are exceptions that can come up that your dependencies may not have ever intended to get. It's a new exception, and it may just swallow it. And there are certainly new exceptions that can occur, and you want to know that they're being discovered, that you've got things that are, basically hiding what's going on. So this tool is used to help you get the complete list. So when you run your code on the new JVM, you're going to run this with this turned on as a particular thing and see what turns up. Okay, you sort of need to figure out what you expect, but you will certainly see some new ones coming up. There's this one, sun, misc, unsafe. Who uses unsafe? Nobody's going to admit to unsafe, right? Again, the basic thing is it will tell you a few things, right? Warning, a terminally deprecated method. You may have seen that recently when moving to the latest, to like Java 21 or stuff like that. You see like Maven starting to get warnings and things like that. So you will see that, but you can force some of these errors these warnings on to tell you that you're using unsafe in unsafe ways that are probably going to go away. Java Flight Recorder. Who uses Java Flight Recorder? Okay, right, a few of you. It's an awesome tool, but for some reason it doesn't get used. It's an analysis tool. It's there for you to work out what's going on in your system. There are lots of tools around it. One of the things about it is to help you understand what your performance profile is going to look like, and is it going to change? Because there's at least one major change between 8 and 25, because one of the GC model changes, that could seriously impact your performance. So getting used to these tools to benchmark yourself and then apply and just see how radically different it is. Right, there are one or two things you could do to ignore some of these problems, and defile encoding your compact is one. We'll come back to why that's important. Locale providers equals compact. So there are some finalization equals disabled. There are flags that you can apply to either try out the change before you migrate. So like definalization equals disabled, turn off finalization to see whether it's got impact to you, right? And some of these other ones that are like, well, let's just not worry about that problem yet. And of course, if every one of those, if you do some of these, then you're sort of delaying the problem, but it's definitely there. And the last one, add opens, is the whole modules thing, right? I'll let you go read all about that stuff. It's all fun. So there we go. 5-ish commands, right? jdeps, jdeprscan, jdepscan, looking at your flags, and then looking for sorted exceptions by running -x log exceptions. There are some really great tools for you to use. Right. So let's map this. So I'm now going to go through the bit you really need to know is what's changed. And these things will be, we'll map the tools. So I will point to some of these tools. Okay, so there's a lot. Page 1, breakages by version since 9. All right. We will go through this stuff, but you get some of these things will break you, things won't start, others are silent changes, and some others are in the middle. That's page 1. That's page 2. 17 releases of change, and each of them has a slightly, there's something in there. If you're moving from 8 to 25, you're going to hit the majority of these, and you have to deal with them. And the way they break down, or the way I've broken down, is basically into this. There's like, it won't start. If you take something with you, your VM won't start. There's it starts, but then it crashes. There's the things don't work the way you're expecting. And then the last one is everything works and then you recompile and things don't work, right? And that's sort of the mix here. So what doesn't start? Obsolete GC flags. There's a whole bunch of obsolete GC flags. If they're on the command line, your VM won't start because they are no longer supported and they are illegal. There are the JEPs. So the way I've structured this is there's a lot of that, and then there's basically a set of JEPs you can go read. Okay, right. But there we go. There's already a failure. If you take your launchers and just go, I'm going to replace it with my Java 8 with my Java 25, you could fail out the box from there. Ditto with Security Manager startup flags. Security Manager's gone, right, which is great, but it hasn't quite disappeared. And you can get, by setting the Security Manager, if you were using one, that's now going to fail because it's no longer supported and no longer allowed for you to use it. So again, more JEPs, more stuff going on for you to go read about this stuff. And it's in the article if you're interested. Right. Obsolete GC logging flags, yes. I think you get to see the pattern. There's sets of things that you're going to have in your launcher that do not work, and it will fail. Right? It's a hard failure. Okay. So again, there's a bunch of JEPs and things about that. That's mostly the obvious, it doesn't work out the box. It's just a bunch of things that you try to use, command line options that are no longer supported. That's fairly straightforward. You just got to find out where they're being used in all your scripts. Right? Once you've dealt with that one, then you've got to start with what happens if you launch the JVM and it then dies. And there's a bunch here. Reflections and JDK internals. So there were a lot of things. It basically comes down to like setting accessible. The rules about what you could do to actually reflect on internal things have been tightened up. And so if you set accessible, it will fail, right? Boom, inaccessible object, right? And you know what I said about scanning, using that thing to record all that command line option to record all the exceptions? This is what you're looking for, because that may get swallowed because nobody's expecting it, okay? Again, a whole bunch of information about it. None of this is just gathering of what's out there. Yeah. So what could you do? JDEPS, look for use of JDK internals, turn on the exceptions thing, and see what's being called or what's being swallowed. Okay. Now there's more. There's the obvious things like a bunch of packages got removed over time between 8 and 25. A bunch of stuff. I have a list, but you can go find it yourself. You know what happens. You know, Java EE, Jakarta conversation, a bunch of other stuff disappeared. Corba disappeared. So if you're using those things, they're no longer there. So you're just going to get no class def found, etc. Right. So if you do jdeprscan for removal, that will help you get a list of what has been taken out or has gone. Right. Well, what are you going to do about it? Well, it's just work because there's no workaround for these things. If these things are gone, they're gone, and you have to decide how you're going to re-engineer it. Right. There's all the stuff to go with that one. Right, okay. Right, next one, Nashorn. Anybody using Nashorn? Okay, what about all the dependencies that you'll have in your tree? How many of those are using Nashorn? Do you know? Is it doing little JavaScripty things under the cover? How do you know? Right. So get engine by name Nashorn, or JS, I think, also returns null. Doesn't throw up. It just returns a null. So code that you might have that says get me the Nashorn engine to do stuff is going to get a null pointer, and it's going to abort. Right. It's just going to go boom. Right. So if you're using Nashorn, you can't anymore. So you have to replace it. More links. I got bored putting them as separate pages, but luckily there's less of them. So these things, you start getting to now you've got to start looking at the code, and of course your challenge is you've got to look at the code for your dependencies too. And that's where it's going to start to get sticky, because you need to know. Now you should be able to figure out, I mean, this thing is hard because none of the dependencies, because Nashorn was built in, it's not an extra dependency, right? But you could certainly have dependencies that are making use of that. your choices are, in any of these circumstances, your choices are to do it runtime and detect it because it fails, or to go scanning for, using like Java P or other tools out there to run through the binaries of the class files for you and your dependencies, scanning for the method signatures that tells you that get engines by name is being called. Right, set security manager. Yup, there we go. Another one of these. If you do this, set security manager, you will get an exception, right? It will, unsupported operation exception. Okay, so a lot of this is really straightforward. It's gonna go boom. Okay, that's cool. You know about that, you can fix it. And again, some JEPs and things for you to go read if you're really excited about it. Has anybody actually ever used a security manager? You know, well, I mean, it was bad from the beginning. Right. Okay, and I know because I was there. Right, split packages. So if you're using modules, then split packages where you have things with the same package name in two different modules is no longer allowed, and it will moan at you and it will crash. You try to load one, and it'll go, hang on a minute, no, not allowed, bang. Okay, who here uses modules? There we go, see, you're safe. Let's carry on. Right, so I'll won't even do that one. Right. Now we get a little bit subtle. The bytecode is changing lots and lots and lots and lots and lots. We've had a lot of change, and now it's the class file number changes every release. So the tools that you use to go read class files have got to come with you. You can't use old bytecode manipulation tools for Java 8 if the classes that they're working on, which are either your new ones or the dependencies, are now compiled for Java 25, because even if the format is exactly the same, the class file definition, the version number in the class files changed, and you'll get illegal exception. It's really painful, right? So you have to start looking at those dependencies and making sure you bring them with you. Lots of dependencies you can probably just leave, but there are specific ones that you might need to bring with you. And again, a bunch of stuff you can go read about this if this is your boat for floating. It's painful. I don't understand why they've decided to update the class file format number every release, even when they don't change the class file. It's just irritating because you end up having to go through this sort of stuff. Right, what else have we got? Native access. Right, you can't do native access without having enabled native access on the command line, right? Because they're trying to limit this. It's a security exposure. So if you want to do JNR, FFM, or whatever, you need to tell the JVM that it's allowed to do that. That's it. You're gonna run it, it's gonna crash, you're gonna put this on and you'll be done, right? You can use jdeps from Java JDK 22, but by the time you've got to that point, because you're on 8 or 17, this is later. So you're effectively in this situation where you're likely just to bounce. It's just like you're going to fail. At least you'll know what's going on. It's nothing. It's just a security flag. Of course, you might want to go ask yourself why you have all that native access, but that's a different thing. And again, a whole bunch of stuff you can go read about. Okay, now, unsafe memory access. 79 of 87 methods are going to go. Who uses unsafe? Is that you use unsafe, or you asking a question? You use unsafe. Cool. You're good. The only person in the room. I can talk a lot about it, but since there's only one person, we'll skip. But it's going away because it was always a very bad idea. It's just a place to put all of the nasty bits and pieces that a JDK needs to access things from their Java code. It was never meant to be available for application Java classes. Right. But again, if you're interested, there's a bunch of stuff you can do. Yeah. So you can do this some MISC unsafe memory access debug if you want to see what's going on. Right. Right. So that was crashes. What else we got? Runs but fails, or runs but doesn't do anything. No crash, no errors, different behavior. So the first obvious one is the security manager. Now, the reason this is a bit nasty is because where you have do privilege, so the security manager has a do privilege. It says, am I allowed to do the following stuff? And it's supposed to get a yes or no, and then it will do the code on a yes, right? So that code, because there's no security manager, do privilege is, yep, go ahead, right? So it will just go and run straight through. So though it's gone away, it's still there. And if you've got dependencies that are old and assume that they need a security manager and they're going to ask for privileges, even if you're not using them, you might theoretically have some security breach. Okay? And again, a whole bunch of go off and read about it. Security manager, removing the security manager is almost as good as not putting it in the first place, but we have these rough edges. Okay, so that's maybe you're okay with that because maybe you don't use the security manager, so maybe you're okay. There are other changes. Locale data, right? Now, you can turn this off, this -d Java local provider, you can do that. But basically, the default of the locale, it was just switched from I think basically whatever your machine was set up to a particular form of Unicode, right? So why this is insidious is that you see the red and the figure. So the red was before, you got the before and the after. So output that you might think was going to be a particular format can now change. So you think about you're writing code, you're writing data, I don't know, in file names or things. In the wrong circumstances, you're now going to find that what you had before in Java 8 produces different output because they've changed the locales. Okay? The bottom one is actually a date. I mean, you can see what the date is. Right? So if you've got local time date, there's a 2017 thing, and you format it for a particular language, right? The code doesn't change, but because of the choice of defaulting, you get two different responses. Okay? So if you do anything with locales, if you're anything where you're running your code in different countries, you could hit these sorts of problems. And again, a whole bunch of information about it. You need to run your locale sensitive tests before you go too far so that you can get ahead of what's going on. It's hard, right? Because you've got to figure out that you've got the problem in the first place. Okay. Similarly, UTF-8, the default char set, it used to be not UTF-8. And we used to have quite a lot of times when people were setting things to UTF-8. Maven has UTF-8 as a property, so you can say everything's in UTF-8 because we want to be standard. Well, it became standard, and the consequence of that is that now the code that comes out can be different. So unless you know this is happening, then you could have unexpected results. And of course, anywhere where you're turning you're expecting to interoperate the operating system or human beings, a place like that, you could hit this change. This could cause you something. You can turn it off with this file encoding equals compat, which is fine for now, but you're going to have to deal with it. But it's there, right? And as it says, you can go search for all of these classes where there's no particular char set. So that's where you're saying use whatever the default is, because in this situation, the default has changed. Yeah. Silent file IO corruption on Windows. Yay! Right. Okay, let's carry on. We still got more. Right, now this one. This is different behavior, but it's one of those sort of it's a performance change. The GC's changed. Right? So in theory, it's a no-op. You just run a different JDK, everything works. But of course, because the GC's changed, your performance might change. You might run out of memory because you have you're using a different GC. So it's more a warning to say you need to make sure that the GC models that are in the new one are going to be applicable to your workload. And you need to understand that these things have changed. And again, if you want to know more, do this, or you can use JFR, and you can do the really nice detailed profiling of your application to see what the difference is. It can be a long weekend to make this change, isn't it? Okay. Other things. I'm not sure where to put this one. So this is an unsafe thing. It says, you can see object field offset. So you could literally find locations of fields. And you can find offsets within fields. And that worked fine, but it was all based 100% on the way the objects were laid out in memory. So if your code is designed to work with a Java object as it's defined in Java 8, this is the sequence of things, this is how a class will look in the disk. When you move to Java 25, because class file formats, object headers, a whole bunch of stuff changed, any of that code is now going to not understand and could do nasty damage to your system because it's basically writing to memory. Okay, so if you're using unsafe, which hopefully this will catch because the previous restriction on using unsafe, but be aware that turning unsafe back on isn't necessarily the panacea because it may just be completely wrong and you just need to chuck it away. Chances are it's not in your code, but it could be in dependency. Right, more of those. You can say the memory access debug will give a list of what's going on. So you've got tools to help you find it out, but a lot of this is fairly nasty. And again, you probably want to start looking at the bytecode for things like object field offsets, looking for the methods that are being used. Okay. Thread group degradation. So thread group hasn't quite gone away, but it's not really used. It doesn't really do anything. So like destroy is a no-op, but if you use thread group stops, append, resume, you get an exception. Okay, now that came out, was it 20? Yeah, so if you're on 17, you're not hitting this, but of course when you move to 25, you will hit that. This is the sort of character of what we see. There isn't much change, but occasionally you'll find something that the changes that if you're using it, suddenly you're going to get an exception. Right? And I think a lot of that design principle is to try and make you aware that you're using things that you really shouldn't be using anymore. And there's the URLs and the details for that one. Okay, right, we're getting there. Right, next one. Finalization. Who even knows what finalization is? Okay. Anybody who's not a JVM? Yeah, okay, right. Finalization is this really nasty hack. And I know because I was there when we added it. And it was one of those regrettable things, finalization, and a bunch of other GORP that was there to help you manage external resources. It's sort of like we've gone, it's just a bad idea. So we're not going to use it anymore. So you've got, where have you? You've got finalization equals disabled. So you can, if you're on Java 18, you can see what the effect is because you can simulate it with this property to see whether it will break your system. If it doesn't break, then you're fine. And again, it's going to be really old code that's going to be doing that. I mean, Java 8 will certainly have dependencies that could have make use of finalization. Just things won't happen. Things won't get cleared up. And you may find that external resources don't get recovered. And so suddenly you run out of system memory rather than JVM memory. Some things could happen. So it's certainly worth looking in your dependencies to see if anybody's using finalize. And again, look, more things. It's Finalize is just horrible. But of course, the fact that it's horrible doesn't mean that people don't use these things. What do we got next? Okay, recompilation styles. We're getting there. Okay. So this is, your code works fine. As you take it from Java 8, you put it on your JDK 25 machine, and it works, and you've dealt with all these things. You haven't had to recompile. You run it, it's good, and you go, okay, let's recompile. Because you're going to want to recompile, because recompilation is going to give you a big performance boost. And just moving from 8 to 25 is big improvement. And recompilation will give you some of that because you get new bytecode sequences, and the compilers and the JITs and things know those. So you get more just by recompiling. But there are some edges. So serialization. The problem here, you have to bear with me, I'll try to explain this. So serialization, which is to take an instance of an object and stick it on a disk and then bringing it back. The format of the data that goes on disk is defined by the shape of the class, what fields it's got and things like that, the type and order. Okay, now, if you're using Java 8 and you serialize an instance of an object onto disk, and then you try to bring that data back onto 25, it will work if you haven't changed the class, if you haven't recompiled the code. If you recompile the code, the structure of the class has changed, and so the serial version ID will be different. And so you will get an invalid class exception. So any data that you've got in your system anywhere that is created by serialization could break when you try to bring it back. Okay, and I will explain. I haven't got a picture to explain. Okay, so there is a way to fix this, but it's complicated. But what you can do, right? So remember, you can't, if you recompile the Java 8 classes on Java 8, that's fine. If you recompile them on Java 25, things will break because this field, serial version UID, is generated if you don't provide it. Now, if you've provided it, it's not a problem because you've taken control. If you haven't provided it, this change is going to happen, you're going to break. So the way to do this is that you run the tool called serialver on the class on Java 8, and you'll get a number. And then you change your code, and you add in the serialver equals that number, and then you recompile the Java 8 class, okay? That way you've got a UID that matches the data, so you should be able to deserialize whatever you've got, that should all work. But then also if you recompile that code with that new serial version, new UID in it on Java 25, it will still work because that says to the JVM, take this number, don't worry about calculating, because that error, invalid class exception, comes because it's calculated this serial version ID, which is the shape of your class. Okay, that makes sense? You have to be really careful about that. If you're doing serialization, then this is a really nasty edge case, and you don't want to get bitten by this, and you certainly don't want to end up with data with mixed versions in it because it'll cost you a lot to get out of it. What else we got? Underscore as an identifier. I didn't even know I could do this. Did I really know you could use underscore as a version name, as an identifier? Right, well, it's now a keyword, so if you did, you can't. Java lang IO. So this one is a generic one, but IO seemed to have pulled it up. People brought this one up. If you do star imports, you run the risk. So if you've got, you've got some class, and then you've just import blah 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 dot star, which is obviously import everything, and you've got 2 or 3 of those, and then you reference a class, you know that you might get the compiler go, well, which one? Because I've got I've got linked list and I've got AWT list. Which one do you want? Okay. Apparently, introducing IO, people have moaned because other people have created their own IO classes. So it's basically ambiguous references. So the generic thing is if the JDK creates new classes that have got names like things you might have created, you might potentially get this at compile time. It's a niggle, and that's all it is. Okay. This one is not a niggle, but this one is interesting. I'm trying to find an actual example. So I've heard about it, and I understand what's going on. So this is when you create a string and you add stuff, you do appends, right? You know, this string equals this plus 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 this, right? It's all appends. Under the covers, there's a bunch of machine code, bytecode that's created to say, do these operations. That's changed. When you recompile, the bytecode that you would get for string A equals string B plus something is now changed to use invoke dynamic, make concat with constants. So mostly that you shouldn't care. Unfortunately, because of the way that invoke dynamic works, it means the ordering of those appends might change. So that means if you're trying to build strings by taking an object and doing a toString on it, which is like because that usually means you're going to ask the object to do some calculations. Well, the ordering of that might change. And so the output may be in a different order than you expected. Okay, that's there. And I said, I've read about it and I haven't yet got an example, but I understand why it's a possibility. So I'd be really interested if anybody actually hits it. Right? So that's just to say, if you run to Java 8 and you go, why is B before A? You'll know it may be because of something like that. Right, really running out of time. The Lombok trap, this is more to do in general with annotations. So since Java 23, Java C compiler does not run annotation processes by default. Annotation processes get discovered because of the where they are. And Lombok is obviously one of those that a lot of people use. But they just don't get generated. And you won't know that until you load the class up and try and call it and the methods aren't there. Okay. This one is a performance thing that you don't need to worry about, but it does make a difference. The way that inner classes work, when the way they reference each other's internals was all very clunky. You probably may have seen access methods and things. That's all changed. They have a new high-speed thing, which are called nesties or nestmates. It's much faster. So if you recompile, you'll get performance if you use inner classes and things like that, just really from that thing. Oh, right. I think that's all of that I can tell you about the changes that I'm aware of that are there. It's a wide range of stuff. Most of it is okay. This is going to obviously cost you work, but it's not like you have to rewrite large amounts of code, because this thing, Open Rewrite. Anybody using Open Rewrite? Yeah, okay. So there are lots of patterns already to do these things. So a lot of what I've said, there will be an Open Rewrite pattern, or you can do your own thing. But it's just your code. The challenge you're going to face is, how do I get dependencies that I'm relying on that are hitting these problems to update? So that's a conversation you have to have with a dependency person, or you have to change the dependency, right? But in general, in terms of these pattern updates, this perfect Open Rewrite has all the patterns for you. Blah, blah, blah. Loads and loads of recipes. Right, okay. I wanted to just talk about this because I just want to make you aware. When we talk about dependencies, we're talking about part of a supply chain. You consume code. You've got code, you have dependencies, you make decisions about your code, how you test it, how you deploy it, what your security posture is, when to go end of life. And every dependency that you use makes the same choices. And every dependency they use make the same choices. So on the average for a modern Java application there's 150 of those. So there's 150 groups of people out there making choices about their dependency that affects your migration. So it's not a trivial activity if the dependencies you rely on do not provide you with the fixes that you need, right? But on the other hand, 10% of this application that you're writing, you wrote. I mean, forget the AI stuff, because you're relying on 90% of somebody else's. Those dependencies are the heavy lifting, right? So in the end, all this work about moving from Java 8 to 25, which is not particularly complicated, you're getting enormous amounts of bonus out of this because you're relying on somebody else's code. Right, so let me just tell you, I've got 4 minutes, I haven't got time. 22% of that 90% is maintained. The rest of it has no maintenance, right? So when you start looking for dependencies to replace the ones you've got because they won't move from Java 8 to 25, do not be surprised if you cannot find somebody who's updated that dependency. Right? The major ones you've got Spring or Tomcat, whatever it's going to go. But if you're using any of the other smaller ones, there is a good chance that they aren't going to build it. Right. And I'm going to skip over these things because I haven't got time. Yeah, so it's your dependencies mostly that's going to be your difficulty for you. You've got to figure out how to resolve that, and I can't advise you. I can tell you can come and talk to Hero Devs if you wanted some support for some of those things, but in general, you've got to figure out what these dependencies are and whether they're going to bite you, right? And then you have to deal with it. Obviously, the silent changes are worse than the crashes because the crashes are straightforward and in your face. Be aware that recompilation can change things, so don't do that until you're ready. Get everything else out the way before you recompile, because then you won't know what the problem is, right? And then you can walk away from here and do 7 things. Right? You got a weekend, right? So audit your startup flags. Go check that you've got that they're all valid. That's easy to do because you're going to know if you fail. Run jdeps on, as said, on your class path. Make sure that they'll tell you whether you've got some obvious usage of things that are now banned. Make sure you know what your dependencies are. Come and talk to Hero Devs, and we have a booth. But look at whether or not those dependencies can give you an upgrade, because that's going to change your decision. Because if they can't, you've got to do something else. Run xlog exceptions when you first start testing this to look for exceptions you weren't expecting that are unusual, because they may be things you need to deal with. Yeah, test all binaries and recompile binaries separately. Be considered in your migration plan. Don't just recompile and hope. Take these steps, right? And then just use open rewrite for all of the mechanical pattern matching. There we go. Why would you use 25? Virtual threads, GC improvements, 20% throughput, just so much more stuff. You've got so many vendors. And the main thing is, if you make this journey from Java 8 to Java 25, and you stay on that cadence, you will be on the edge, obviously, but you will be more safe than staying when you are, and you won't have any of these nasty surprises. There we go. That's the end. That's my last page, okay. I thought it was quite good. And then if you want the book, or you want to know about the book, that's the QR code. Come to the booth if you want to know more. And that's the really weird HTML link to my article on Substack, which is basically most of this talk. That's it. Thank you very much.